Okay. Assalamu alaikum and good morning, guys. Welcome back to Inspire Teens, grade 11 maths, where in today's lesson, we'll be continuing with trigonometry. Okay, just before I continue, can you guys please confirm that you guys can hear me clearly? You guys can see my screen. You guys can see me as well. Okay, perfect. Okay, so it's been a while. Okay, welcome back. So just a reminder, okay, for just a reminder sake, or for those of you who are joining us for the first time, if you have any questions, please feel free to ask them in the chat. You can use the everyone or the host and panelists, which is private. You can use the Q&A, which is not everyone will see. But ideally, you want to ask in the chat so that everyone can benefit, because either I'm going to read your question out loud, so it doesn't really matter. Or for those of you on YouTube, you can use the YouTube chat as well to ask questions. Okay, please do note that two more things. The recording, the session will be recorded and it will be uploaded to the YouTube playlist. Okay, and the link for the playlist is in the group description. Okay, or in the message that you have. And that's the first thing. And the second thing is the notes as well. Whatever notes that we do, the PDF document will be uploaded to the Google Drive, and the Google Drive is part of that same set of links, either in the group description or in the message that you have. Okay, cool. Admin done. Let's start. So we did trigonometry, right? So we started, okay, obviously we started with like the basics, and we moved our way. We did reduction, we did special angles, Cartesian plane questions, in terms of questions, trigonometric identities. Okay, that's a tough one. We solved some questions there. And now finally, okay, we need to complete general solution, and we need to complete trigonometric functions or trigonometric graphs. Okay, let's just see. Okay, so with you guys, the next topic that we'll be doing, since we're almost done with trig, is going to be Euclidean geometry. Okay, maybe because there's 3 topics that I allocated for term 2, I'll put a poll in the group, and then you guys can vote whether you want to do Euclidean, analytical, or function. Okay, but yeah, without further ado, let's begin, and let's start with general solutions. Okay. So general solutions, okay, we're going to do 4 different cases. Okay, 4 different cases of solving a general solution. Okay, so all of these cases, by the way, let me get my notes out. 1 second. Okay, there we go. Sorry, I forgot to include it in the notes, but it's fine. I'll take note of it now. So firstly, let us go through the general solutions, okay, of each trigonometric cofunction. So these are not given in your formula sheet, so it's important that you memorize them. Okay, so let's first go through the general solutions of sine. So sine has 2 general solutions. The first one is that x is equal to the ref angle plus k times 360. Okay. The second is that x is equal to 180 degrees minus the ref angle plus k times 360. Okay, and if this sounds like gibberish to you, don't worry, it will make more sense when we do an example. Okay, then if we talk about the cos general solutions, it also has 2. The first one is x, which is our angle, is equal to the ref angle plus k times 360. And the second one is x is equal to the negative ref angle plus k times 360. And finally, we have tangent, okay, which has 1 general solution. And that is x is equal to the ref angle plus k times 180. Okay, that one is easy to remember. Okay, remember that tangent has a period of 180. The tangent graph has a period of 180, and that's what's going to help you remember that that's 180. Okay, so these are the general solutions for sine, cos, and tan. So when we deal with a single trigonometric ratio, okay, single trig ratio, this is how we solve for it. Okay, so it's relatively simple when we are dealing with a single trig ratio. So let's just say we have the equation 2 sine x minus root 3 is equal to 0. Okay, 2 sine x minus root 3 is equal to 0. And we are told to solve for the general solution of this equation. Okay, so the first step, okay, always is to isolate your trigonometric ratio. So your sine x, you want to leave it alone. Okay, and what's attached to sine x? What's attached to sine x is the root 3 and the 2. So we can start off by saying 2 sine x is equal to positive square root 3 because we took it over to the other side. And then we can divide both sides by 2 to get rid of the 2. So it becomes sine x is equal to square root 3 over 2. Okay, so we've done the first step completed where we've isolated the trigonometric ratio. That sounds fancy, but it just basically means I left sine x alone. Trigonometric ratios are sine, cos, and tan. Okay, so whenever I say that, that's what I'm referring to, sine, cos, or tan. Now, in this case, this is where, okay, so that was simple enough, okay, just isolating the trigonometric ratio, that's like algebra. But now this is where it comes, where this is where the step comes in to solve actually for the general solution. This is like our first step, kind of, right? So what are we doing next? Let's work there. We are finding what we refer to as the reference angle, okay, which we just shortened as a ref angle. Okay, this is a little symbol for an angle. So we are finding what we call the reference angle. There's no need to understand what it is. I teach you the method, you know the method, you solve the question. Okay, so the reference angle is found how? It's found by taking the inverse of sine. Okay, so sine to the -1 of whatever sine is equal to. Okay, which in this case is root 3 over 2. So I take the inverse of root 3 over 2. Of course, the sine inverse of root 3 over 2. And whatever answer I get there, so how do you solve for this? You put it in your calculator. So in your calculator, you're going to say shift sine. Okay, the sine symbol is like on the 3rd row, the 4th button, and then shift is on the, okay, you guys should know this. Shift sine root 3 over 2. Okay, and then when I say shift sine root 3 over 2, you're blurring it out, but you get 60 if you try. So you don't have to get a whole number. You don't have to get a special angle. It could be it could be a number with decimals. It doesn't really matter. But in this case, we're getting 60 degrees. So our ref angle is actually 60 degrees. So if we look at our general solutions and we see ref angle, ref angle, ref angle, ref angle, this is what we're talking about. Okay. In this case, this ref angle that we just solved for is 60. Okay, since we are dealing with sine, now that we have the ref angle, since we are dealing with sine, we are going to use the general solutions for sine, number 1 and number 2. So we have to draw up 2 general solutions. So the first general solution is always, so this x, by the way, let's just say that these are the general solutions of sine x, cos x, and tan x. Okay, where what goes on the left-hand side is actually the angle, okay, of the trigonometric ratio. Okay, so whatever angle is attached to that trig function, which in this case, it's x. So that's why we wrote x on the left-hand side. If you want the general solutions of sine 3x, okay, your general solutions would be 3x is equal to ref angle plus k times 360. And your second one would be 3x is equal to 180 minus ref angle plus k times 360. Okay, so just keep that in mind. That's important. What goes on the left, it's not always x. Okay, it's just whatever the angle of your trigonometric cofunction is. In this case, it's x. It could be b. It could be 72 minus b. Okay, it could be anything, whatever is attached to that trig ratio. So in this case, what's attached to our trig ratio? It's x. So our general solutions will be x is equal to ref angle. Now we actually have a ref angle of 60 degrees plus k times 360. And our second one is going to be, again, what is our angle? X. Okay, x is equal to 180 minus ref angle, so 180 degrees minus 60 degrees plus k times 360. Okay, we also then need to simplify our general solution. So we have two, but yes, we need to simplify them. Okay, so let's simplify them. The first one doesn't need to be simplified, so I can simply just rewrite it. X is equal to 360 plus k times 360. Okay, and then the second one, x is equal to 180 minus 60, that's 120. So I just simplify that to 120 plus k times 360 degrees. Okay, so that's basically with a very basic example, again, with a single trig ratio. Okay, so single meaning just one, it's just a sine x. When we do double, you'll see we'll have like sine x plus cos x, for example. Okay, so just a single trigonometric ratio. How to solve for its general solution? First step, isolate the trigonometric cofunction sine x. The second step is to then solve for its general solution, okay, which is to first find the reference angle by taking shift of the trig ratio. So in this case, it was sine. So we said shift sine, whatever sine x is equal to find that reference angle. Once you have the reference angle, you substitute the reference angle as well as the angle itself into the general solutions. Again, these general solutions are not given in your formula sheet, so you need to memorize these. Okay, they're relatively easy to memorize. Okay, let us go a bit further. So they don't always just stop there. Sometimes they may ask, especially in grade 11, they definitely will ask. Towards grade 12, they generally don't ask because of, okay, whatever the reason is. But what they tend to ask further than this, okay, than finding the general solution, is they give you an interval and they ask you to actually solve for the values of x. So what that looks like is the question will be like 2 sine x minus root 3 is equal to 0. And then they'll say, find the values of x, or what will they say? Solve for the general solution in the given interval. And they might give you an interval. Okay, they might give you an interval. They'll say x is an element of negative 360, negative 360 degrees to positive 360 degrees. So this interval, they want you to solve for the values of x that fall within this interval. Okay, you'll see normally the question will be attached together. So let's maybe just copy this. Okay, so they'll have this part of the question and they'll have this part as well. Okay, so they want us, again, to solve for the general solutions for which x is in this interval. Now, we already solved for these general solutions, right? Let's take them down. What's going on? Sorry, my pen is not writing for some reason. Give me 1 second. Let me try to fix it. Okay, there we go. It's working. Let me share my screen once more. Okay. Okay, so it should be fine now. There we go. Okay, so yes, we solve for these general solutions. So let's just take them down. We have x is equal to 60 degrees plus k times 360. And we have x is equal to 120 degrees plus k times 360. So these are the general solutions we solve for. Now, how do we solve for specific x values within the given interval? Okay, so that's simple. What is going on here, man? Okay, so that's simple. what we do every time is we solve, we give it certain, okay, I'll write it down in 1 second. There we go. Okay, so each time what we need to do is we need to take our general solutions, okay, and plug in values for K. Okay, we plug in specific values for K and we try to find the corresponding X values that fit within that interval. So we always start off with 0. Okay, so we try it out. Okay, we plug in K is equal to 0. Okay, so then what we do is we take 0 and we substitute it into each equation and we see what we get for X. So if we do it for the first one, you don't have to write all of these out. You're going to do it just in your calculator. I'm just writing it out so that you understand. Okay, and of course, this is going to simplify as X is equal to 60. So when you substitute 0 for K in the first equation, you get an X angle of 60, and 60 fits within that interval. So that's one of your answers because it fits within the interval. So you will say when K is equal to 0, X is equal to 60. Okay, but you have a second equation, so you can try and plug it into the second equation. So X is equal to 120 plus 0. So you plug in K in the second equation, plus 0 times 360. And here you're going to get X is equal to 120. 120 is in your given interval. So you can say while K is equal to 0, X is equal to 60 and X is equal to 120. As long as it's in your interval, you're going to keep writing them down. They're not going to give you an interval where you're going to fit 500 angles. At most, you're probably going to fit about 3, right? But let's try further. So always what you want to do, you want to substitute values for K. So you're going to let K equal to 0, 0, start off with 0. Then you go to 1 and -1. Then you go to 2 and -2. Okay, then you go to 3 and -3. But generally, you will see that they'll stop falling in your interval around the -1 or 2 mark. Okay, not guaranteed, but most likely. They're just going to ask like maybe even 0 and 1 and -1, whatever. Right? You'll see the more examples you practice. But now let's try 1. Okay, so I'm not going to write it down, but I'm going to plug 1 into this. Okay, I'm going to do it in my calculator. So I'm going to say 60 plus 1 times 360, which is basically 360. And it gives me 420. So when I plug 1 in, I'll just write this one more. X is equal to 60 plus 1 times 360. This gives me 420, which is not within my given interval. It's past 360, so I will not take it down. That's why I won't even write K is equal to 1 just yet, because I know that for now, when I plug K in, I'm not getting a value within the interval, so I don't write it down. So let's try and plug it now in the second equation. So we're going to try and plug 1 in the second equation. So X is equal to 60 plus, not 60, 120. 1 times 360. And this gives us an even bigger value of 480, I believe. Okay, and this is not within our given interval, so I don't take it down. Okay, but doesn't mean that 1 doesn't work, that -1 won't work. So you try -1. Okay, again, please, all of these calculations that I just shown, you don't have to do this, right? In fact, don't do it. You need to get used to just doing it straight in your calculator. I'm just writing it so that you guys can understand what I'm doing. So let's try -1. So here we tried 0. Here we tried 1. Now we're going to try -1. Okay, so in equation 1, I have X is equal to 60 plus -1 times 360, which basically becomes 60 minus 360. And you will see that this gives you a value of -300, which fits within our given interval. So now I will actually write this down. So I will say when K is equal to -1, X is equal to -300. Again, I'm writing it down because it fits within my interval. Then I plug it into the second equation. X is equal to 120 plus -1 times 360. And when I do this calculation, 120 minus 360, basically, I get X is equal to -240. So that definitely fits within my interval. Negative 240 is between negative 360 and positive 360. So again, it works for the second equation. So while k is equal to -1, the second value for x that fits within the interval is negative 240 degrees. Now, when you try to plug in 2, so obviously we did 0, we did 1, we did -1. Let's try 2. Okay, when I try 2 for the first equation, it doesn't work. I get 840. When I try, sorry, for the second one, I get 840. For the first one, I get 780. So now the numbers are massive and they're just going completely out of range. Now, if I try -2, I get negative 660 and I get negative 600. Okay, so also beyond the range towards the left side. So once both numbers don't work, that's generally when you're out. When 2 and its negative doesn't work, that's generally when you're out of your interval and none of the numbers further are going to work. Okay, but for now we tried the first 3 and the first 3 worked. Okay, and we got 1, 2, 3, 4 answers that fit within interval. Okay, so just keep that in mind. That's how you would solve the question when they ask the specific interval. Again, please do not do that long calculation. You're just going to sub it into your calculator and see if you're going to get an answer that fits in your interval. If in your calculator you see that it fits in your interval, you write it down. Okay, please, if you guys have any questions, feel free to ask. Otherwise, I'm going to move on. Okay, so let's just recap what we did. We discussed general solutions. Okay, the general solutions for each trigonometric ratio. So sine, cos, and tan. And we discussed how to actually solve a general solution for a single trig ratio. Okay, so single trig ratio could be sine, cos, or tangent alone on its own. Okay, so now we will get practice with cos and tan in a bit, right? While we do the more complicated examples as well. So let's move on, okay, to general solution. I forgot to add. More specifically, okay, with 2 trig ratios. General solution with 2 trigonometric ratios. Okay, how do we solve those? So what does an example look like? Let's have a look. Okay, so an example is like this. Before we read the instructions, we look at what kind of example. We have 4 sine 5x is equal to 3 cos 5x. Okay, so this is not like the first example we did. This is a bit more complicated, right? Now we have, again, 2 different trigonometric ratios. So how do we solve that? Now, all of these steps, step 1, 2, 3, 4, Roman numerals. Okay, these are steps in which you should follow to try and solve your general solutions with 2 trigonometric ratios. So the first thing you should check for, if the angles are the same. The second thing you should check for, okay, so if the angles are the same, you're going to follow this. If the angles are not the same, you move on to step 2. You check if the coefficients are the same. If the coefficients are the same, you try to follow this. However, if the coefficients are not the same, you move on to step 3. You check if you can take a common factor and follow these steps. If you cannot take a common factor, you try to see if it's a trinomial. Okay, so you do these steps in order, and that's how you try to solve these questions. So now let's do each one individually. So let's say we have this question: 4 sine 5x is equal to 4 sine 5x is equal to 3 cos 5x. So we follow our first step. Number 1 is to check if the angles are the same. So if we look at our equation, we can see, oh yes, indeed, the angles are the same. We have 2 different trig ratios, but with the same angle, 5x and 5x. Okay, so now we solve accordingly. Let's get that. Okay, so the instruction says to divide both sides by cos to make tangent and follow tangent. Okay, so let's do that practically. So in this case, we have sine x and cos x. So whenever you have this example and you have the same angles, you should divide both sides by cos x. Okay, but technically you're just taking cos x to the other side. Okay, so you're going to divide both sides by cos the same angle, cos 5x. So when I divide this by cos 5x. So here, the cos 5x and the cos 5x cancel because it's the same thing. Again, like I said, it's like taking cos 5x over to the other side. It's the same thing. Okay. But on this side, I have an identity. Sine 5x over cos 5x is actually what? It's actually 4, because the 4 stays the same, the coefficient, 4 tangent 5x. It's actually 4 tangent 5x. Okay. And this is equal to 3. 4 tangent 5x is equal to 3. So now we've taken the two trigonometric ratios and we've simplified it into one trigonometric ratio. Okay, so now we have an equation with a single trig ratio. So we solve just like how we solve this. Isolate the trig function and then solve for the general solutions. So let's do that. Isolate this guy. Tangent 5x is equal to 3 over 4. Okay, now I need to find my ref angle. I say shift tangent 3 over 4. Put that in my calculator. Shift tangent 3 over 4. And I get 36,87 degrees. 36,87. And that's my ref angle. Okay. So now that I have my ref angle, I follow my general solution. So my general solution for tangent x, okay, is x is equal to ref angle plus k times 180. So I follow that as well. So I will have x is equal to ref angle plus k times 180. I'm just going to write it here on the side. Okay, this is the general solution for tangent. Okay. However, in this specific case, remember my angle is 5x. So it's going to be 5x is equal to ref angle, which is 36,87 plus k times 180. Okay. Now I need to leave x alone. So I need to simplify it as much as possible. So how do I do that? I have to actually divide both sides by 5 to get rid of that 5 because I want to leave x alone, okay? To simplify it into its most simplest form. So when I leave x alone, I actually can divide each term separately by 5 to make life easier. Okay, and I have x is equal to, when I say 36,87 divided by 5, I get 7,37 plus k times 180 divided by 5 is basically like you're just going to divide 180 by 5 and you get k times 36. So in its most simplified form, this is what we have. 7,37 plus k times 36. Okay, again, they could also ask you to solve for specific values within a given interval, and you would do it the same as this. Okay, but with regards to how to actually solve this general solution, or actually how to simplify it at first, okay, to get it to one single trigonometric ratio, this is what you do. So when the angles are the same, okay, and you have obviously a sine and a cos, not like tangent and cos, it has to work with only sine and cos because you want to create tangent by saying sine divided by cos, but ensuring that the angles are the same. So when the angles are the same, you divide both sides by cos, and this obviously cancels because sine, cos 5x divided by cos 5x is just 1. 3 times 1 is just 3. Okay, and then when you simplify sine 5x over cos 5x, you get tangent 5x. Then you have one trig ratio. Isolate your trigonometric ratio and solve for the general solution. Okay, let's move on. So let's just say we have an example. Okay, let's just say we have an example, okay, where if we look at it, which we are going to do now, and we try to follow step 1, we have a sine and we have a cos, okay? But we try to follow step 1, and step 1, the first rule says, are the angles the same? And in the first one, it worked because the angles were the same. But in the second one, if we have a look, we can see that the angles are not the same. This angle is x minus 30. This angle is 4x. The angles are not the same. The first one will not work. Then we look at rule number 2. The question number 2 asks, are the coefficients the same? And if we have to look at this, we can see, oh, indeed, the coefficients are both 1. So the coefficients are the same. So the question says convert either sine to cos or cos to sine using 90 minus. Use the trig ratio obtained. Okay, so let's follow this first step and see how we answer it. Okay, so why are we using 90 minus to convert sine to cos or cos to sine? Because remember, whenever we deal with 90, if you remember from reduction, whenever we deal with 90, okay, we can actually go back to it. Yes, here we go. The 90 and the 270 rule. Okay, whenever we're reducing sine or cos with 90, then sine changes to cos and cos changes to sine. So it is possible for us to utilize 90 minus to change from sine to cos or cos to sine, right? So in this case, right, the easier one you could actually work with is cos 4x. Okay, so sine x minus 30 we can leave the same. And we equate this to, so what you should do is, you should automatically, the first thing you should do is change your cos to a sine. And in brackets, instead of writing 4x, you want to write 90 minus 4x. Okay, and if you remember from reduction, you'll notice that sine 90 minus 4x is actually the same thing as cos 4x. Because if you have to reduce this, 90 minus is in the first quadrant where everything is positive, and sine changes to cos. So it actually reduces to cos 4x. It has the same value. Okay, so just keep that in mind. I didn't change the value of anything, but I use this 90 minus reduction to change cos into sine. Okay, now we can simplify accordingly. So what we should then do is we should take one of our angles as our angle and the other angle as our ref angle. So angle, and this is our reference angle. Okay, and then the second rule says use the rule of trig ratio obtained. The trig ratio that we obtained here is sine. Okay, so the trig ratio, sorry, the general solutions for sine are as follows. We have x is equal to ref plus k times 360, and x is equal to 180 minus ref plus k times 360. Okay, you need to memorize those. So in this case, I'm taking my angle as x minus 30 and my ref angle as 90 minus 4x. Okay, always do that. Take your angle and your ref angle. Whenever you're doing an example like this, take the first one as your angle, second as your ref angle, and go accordingly. So angle x minus 30 is equal to ref angle, which is 90 minus 4x plus k times 360. Okay, and then I have my second equation. So this is my first one. And my second one is going to be x minus 30, which is my angle, is equal to 180 minus ref. Please use brackets. 180 minus open brackets. Our ref has two terms, so we have to use brackets because the negative is going to affect it. 90 minus 4x plus k times 360 degrees. Okay, so I've written the most basic form of my general solutions. Okay, angle is equal to ref angle plus k times 360. Angle is equal to ref angle plus k times 360. Angle is equal to 180 minus ref angle using brackets, okay, plus k times 360. Now let's simplify my general solutions. So the first one simplified would be, I can actually take 30 over. Okay, so again, you want to be solving for x, you want to isolate x. So what I'm going to do is I'm going to take 30 over and bring 4x over to the side to get all the x terms on one side and all the non-x terms on the other side. So this is actually going to become x plus the 4x from the right-hand side. If you don't understand the simplification, please let me know. X plus 4x is equal to 90, which stays on the right-hand side. Okay, and I bring this 30 degrees over as a positive because it's negative on the left-hand side. It comes over as a positive plus k times 360. Okay, then I simplify my second one. Okay, in the second one, I can take this 30 over. Okay, let's leave it as x minus 30 for now. Let us simplify the right-hand side first. I have to open up this bracket. I have to basically multiply the negative. Look, you can probably skip as many, not too many, but you don't have to write as much steps as I'm writing. If you're better at algebra or if you're good at algebra, you can do your algebra in slightly shorter steps. That's perfectly fine. But I'm just taking it step by step. 180 minus 90, and then minus minus becomes plus 4x plus k times 360. Okay. Again, we can simplify further. So my first equation simplified. I have 5x is equal to 90 plus 30 is 120 plus k times 360. I have, okay, so now I can try and get my x terms on one side and my non-x terms on another side. So it actually becomes x minus 4x this time is equal to 180 minus 90. 180 minus 90 is actually 90. Okay, I bring the 30 over, it becomes plus 30 plus k times 360. Okay, then I'm just going to simplify this guy. This becomes negative 3x is equal to 120 plus k times 360. Now I simplify both of them to their final state for number 1 and number 2. So how do I simplify this one? By dividing both sides by 5. Okay, you can divide each individual term by 5 as well. So that and that cancels. And then I'm left with x is equal to 120 divided by 5 is, who knows, should be 24. Okay, so I get 24 plus 300. Don't forget to divide 360 by 5 as well. And that is 72. Okay, then I can simplify this as well by dividing everything by negative 3 to leave x alone. When I divide everything by negative 3, okay, I get 120 divided by negative 3, which is, so x is alone now. I get negative 40 minus 360 divided by negative 3 is minus k times 120 degrees. Okay, if you've done this already and your teacher told you to leave it as positive, that's perfectly fine as well. Both answers will be acceptable. Leaving it as positive 120 or negative because we divided by negative. Okay, and these are the most simplified forms of our general solutions. For this specific question. So again, you're probably going to go straight from this step to your final step, or straight from this step to this step to this step. You're skipping 1 or 2 steps. Perfectly okay. Okay, as long as you understood the algebra. Okay, the algebra is okay, that's algebra, that's not really trig, but as long as you understood the trigonometric part of it, okay, how to find the general solution of this, we check coefficients are the same with different angles. We convert either sine to cos or cos to sine, and then we use the rule of the trig ratio obtained, and we write out the general solutions. Again, using the first one is angle, second one is ref angle, and solving accordingly. Let's just do the example. If we had to do what? If we had to, instead of changing this cos to a sine, let's change this sine to a cos. I'd show you how to do it, the first few steps. So we have sine x minus 30 is equal to cos 4x. Okay, so the ruling is just go straight from from sine to cos, and then say 90 minus your angle. Please use brackets. If you do not use brackets, you are going to get it incorrect. So 90 minus x minus 30. 90 minus whatever the angle is, this becomes cos 90 plus 30, 120 minus x is equal to cos 4x. And then you solve the same, where you use the first one as your angle, second one is your ref angle, and you move on with life. You solve the general solutions, but this time you use cos. Okay? So you can try that out on your own as an exercise to see, do you end up getting the same answer? Okay? Hope that makes sense. Let's move on. Okay, so what happens? Sure, I understand. What happens? I don't know why these are not completely gone. What happens when you try number one, doesn't work. Try number two, it doesn't work. So angles are the same and coefficients are the same. Let's go to this question. And we look for angles are the same. So angles, because we have a squared term and an x, angles are not the same. Okay, because one is going to give you a different answer than the other because one is squared. Okay, so the first one doesn't work. Angles are not the same. The second one, coefficients are the same. That doesn't work because the coefficients are different. So we try option number 3. By the way, the more questions you do, the more practice you do, the more you familiarize yourself with the questions, with the type of questions, you're most likely going to stop doing it in order. You're just going to look at a question and you're going to be able to know what to do. So instead of saying, okay, let me try number 1, let me try number 2. Oh, okay, both of those don't work. Okay, it's common factor. The more practice you have, you're going to eventually be able to say, okay, wait, this is common factor, and done. Okay, so just keep that in mind. 1 second. Okay, so let's have a look at this example. So yes, the first one is not true. The second one is not true, meaning angles not the same, coefficients not the same. So we try the third step, which is common factor. Now, just as an important disclaimer here, do not divide both sides by sine x or cos x. So this is really, really important, right? So in this example, okay, we technically did divide both sides by cos. Okay, but we also technically did not, because this, all we did was we didn't get rid of cos. Okay, cos didn't disappear. We didn't cancel cos out. Cos just went to the other side. Okay, so that's why it got canceled on this side, because we divide both sides by cos, and here we got 1 and we took cos to the other side. So cos was considered. Cos didn't just disappear. Okay, however, if we have to look at this example, and if you like, oh, wait, I can divide both sides, or I can even just take this sine x over, okay, make this 3 sine squared x over sine x is equal to 2. And then, lovely, no, that's not supposed to be a square. Okay, and then I can cancel one of those on top and one of those at the bottom. Do not ever in your life, as long as you're living and breathing and doing trigonometry, do not ever do that, okay? So when they say do not divide both sides by sine x or cos x, that's what it means. To divide both sides and to cancel terms. Okay, don't ever do that, because you're going to miss out on one of the solutions. You can never just get rid of the sine x. okay, again, you're going to miss out on another solution. So don't do that. So what is the correct method? What is the correct thing to do? The correct thing to do is simple. And you should do this whenever you have the urge. Okay, I know in maths, people don't like to listen to the rules, okay? Because you look at the question like, oh, I think I can do this, and then you don't, you just do it, okay? Because you like, especially like in Euclidean geometry, when the question, when you learn, don't ever assume something is true unless you can prove it. You're like, oh, this looks like a square, so I'm just going to assume it's a square. But you can't do that, okay? So whenever you have the urge to cancel when you're doing general solutions in trigonometry, don't, okay? Just do this. Take everything to one side and try and take a common factor, okay? Don't cancel. When you find yourself canceling in trigonometric, in general solution, a red flag should appear in your brain to tell you, whoa, okay, what am I doing? I'm doing something wrong. I shouldn't be canceling. Okay, just remember it, because trust me, in the midst of an exam, after learning for like 11 months or like 10 months, 9 months, and then the pressure of the exam will get to you and all of a sudden you forget, you just canceling. Okay, so learn it like a parrot, that you should never cancel in general solution. When you have the urge to cancel, when your brain is telling you, hey, I can take this over and I can cancel, always remember this. Common factor, your lovely friend, common factor. Take everything over to one side and take a common factor. So long as you can cancel, you'll be able to take a common factor. So don't cancel, take a common factor. Thanks for coming to my TED Talk. Okay, so what I did here was I took the 2 sine x over to the left, and then because I took it over to the left, what's left on the right hand side is 0. Now what I can do is I can take a common factor. I take a common factor. What color is common factor? In blue. So we write blue. I take a common factor of sine x. Okay. And what am I left with? I'm left with 3 sine x minus 2 is equal to 0. Okay. Now, if you remember, we experienced something similar when we solve for trinomials. Okay. When you have a product equated to 0, each term or each factor in that product, you can equate to 0. So here I can say sine x is equal to 0, or 3 sine x minus 2 is equal to 0. Okay, so now I have 2 solutions, whereas if you followed this, right, let's do the incorrect thing. You have been left with 3 sine x is equal to 2, because you canceled one of the signs. Okay, and then you would have had sine x is equal to 2 over 3. Okay, so let's solve this here. In this case, when we simplify this, you take the 2 over, you take the 3 over, you actually left with sine x is equal to positive 2, because you took it over, it became positive, divided by 3. Okay, and yes, you have one of them, but in this incorrect example, you don't have this one. And you're going to lose a mark for not having that solution because you canceled it out. Don't ever cancel out. Okay, again, this is the incorrect thing to do. Do not ever do it. Let's actually get rid of it. Okay, get rid of it entirely. Pretend like it didn't exist. But again, whenever you have the urge to cancel, just remember, do not cancel. Take out a common factor. Okay, so let's solve it now. So here, I can try to solve for my ref angle. Okay, so what I'm going to have here is, how do I solve for ref angle? Ref angle is equal to the inverse of sine. Let's use a different color. Black is getting boring. Ref angle is equal to the inverse of sine 0, and this is 0. So ref angle is actually 0. But why does it end up working? It ends up working because x is equal to, okay, 0 plus k360. That's not a general solution because we don't have an angle. However, x is equal to 180 minus 0. This is for sine, by the way. Remember, it's ref angle plus k360, 180 minus ref angle plus k360. Plus k times 360. So when you simplify this, you actually end up with just one general solution. And your general solution here is 180. Sorry, x is equal to 180 plus k times 360. So you do end up with one general solution from this guy. And again, if you do the incorrect thing, we won't even mention what it is. okay, you're not going to end up with this. You're going to miss that one out. Okay, then let's solve for here. So let's find its ref angle. Its ref angle. Ref angle is equal to shift sine 2/3. And I get an answer of 41,81. Okay, now that I have my ref angle, I can say x is equal to ref angle 41,81 plus k times 360, or x is equal to 180 minus 41,81 plus k times 360. So if I simplify, my final general solutions are x is equal to 41,81 plus k times 360. And my second general solution is x is equal to 138,19 plus k times 360. If any values are incorrect, please correct me. If you guys are still awake. Okay, and that's the simplified versions of our general solutions. Okay, so that's step number 3, taking a common factor. The more, guys, please practice. Like, maths is about practice. The more practice you get, trust me, it will become easier to spot these things, and eventually you'll be having fun solving it. But yeah, that's it for now. Let's end it there. We'll continue next week, where we'll obviously continue. We'll do trinomial examples. Okay, we'll do some more examples, and then we'll move on to graphs. Okay, and then hopefully we'll be done with trigonometry. And like I said earlier, we will move on to Euclidean geometry, or I'll do a poll and see what you guys want to do first. But yeah, general solution, single trig ratio, and then we solve 2 trig ratios, 3 different types of examples. One where the angles are the same, one where the coefficients are the same. Third, when we can take a common factor. And then the next week we'll do the 4th one, where we do a trinomial, and then we'll move on with life. But yeah, I'll leave the meeting open for a little bit if you guys have any questions. If not, I'll close it after a few minutes, and I will see you guys next week then. Okay, so for those of you who are done and leaving, thank you guys so much for joining. Jazakallah khair. Assalamu alaikum. And goodbye. But yeah, it'll be open for like a minute or so to see if anyone has any questions, after which it will end. And I'll see you guys next week. Okay, since you guys are all very smart and there are no questions, let's end it there. Thank you guys again so much for joining. I shall see you guys next week. I am unmuted, right? Okay. Thank you for joining. Jazakallah khair. Assalamu alaikum and goodbye.